Okay, I think it's recorded. So let's get started. Actually, I'm really glad Banu can join us today. Actually, do you want to introduce yourself to the community, or do we want to do like a round of introduction?
Yeah, sure. Thank you very much for inviting me to the call. I'm a PM in Microsoft. I have recently started with Edge ITC team, which is based out of India. So we are taking over from a PM standpoint the charter for Symphony. And yeah, I'm very excited to be part of this group and learn more from all of you, as well as contribute to the roadmap and make this product a bigger success.
Great, great.
And
Really glad
but
you're
like,
here.
yeah, thank you. And by the way, my name is Banu. So yeah, that's for anyone who's struggling to pronounce.
Great. Thank you, Banu.
Oh, hi guys, I'm Karian. I'm from the Chaos team from Eclipse and Chaos, and yeah, I want to hear the latest news about Symphony. So that's it on my side.
Yeah, welcome. We are going to have an Chaos demo today, so that's something you already know.
Okay, great.
Yeah. How about David?
Yeah, hi everyone. Sorry I joined a few minutes late. I'm Dave Peterson. I'm also I'm from the Microsoft Industry Solutions Plays team, focused in on all things automotive and mobility and transportation across the globe. So happy to participate with the Symphony project as part of those initiatives. I'm based out of Toronto.
Thank you, David. Let me see who's next.
Hello, I am Raresh, just a scholar, and I'm from the Eclipse and Chaos team, and I'm here to learn more about Symphony. Thank you.
Nice. Thank you. Welcome.
Hi, I'm Julien Duquesne. I'm from Schneider Electric, and we are taking a look at Symphony, so I'm here to learn more.
Awesome. Thank you. I think that's everyone. Welcome all. And let's get started with the this month's content. Let me move forward. So today we have a light agenda. So basically we will provide some project updates since we last met. And we'll cover a couple of new features that is in development in the Symphony open source. Then we will provide some updates on the community contents we've been creating. And then we'll have a bit of a Q&A. Just basically this community call is for everyone, right? We want to hear what you think about Symphony, what's the scenario, what the challenges you're facing. So we want this to be like an open forum for you. So first, let's go through some quick project updates. And of course, thank you all for the contributors. We have, I think, about 35 contributors from different companies now. And if I missed some names, I apologize. But I think we are getting more and more external contributions nowadays. And of course, the core, I don't want to say the core Symphony team, but we do have like a development team in China, and also we have team members from India, like Banu. Hey Gabriel, we just got started. Actually, we just went around a round of introduction. If you want to introduce yourself to the community, that'd be great.
Yes. Yes. Hi. Sorry for being late. My name is Gabriel, and I'm from the Chaos team.
Great.
Basically.
Basically. Okay. Let's continue. So I was saying, we thank to all the contributors who's contributing to the project, and so we wish to see more contributions from the community. So in terms of the project update, our current release is 0.48.34. I think we are going to push a new release probably next week. That will be our April release. So the team has been actively working on Symphony. So I think in the past year, we merged about 100 pull requests. So that's like one pull request every 3 days. And the theme of the work is mostly on reliability, scalability, and security. This is why you don't actually see a lot of new features going into the code base, because the theme of this period is mostly to get the Symphony into a more production-ready state. And a bit of history background, right? I started this project about like 3 or 4 years ago as a side project. So I was doing some prototypes, and then eventually it started to build out into a whole system. As you can imagine, right, the code quality kind of varied, depends on the different time I was working on the project. So I really appreciate the team is making a lot of effort to bring the code into a higher quality and to a more reliable, scalable. Actually, they've made some significant changes in the past month. For instance, initially our state seeking process is mostly synchronous, and now it's more handled in a synchronous pattern based on some job handling. So this makes the system more scalable. And of course, the system has gone through like different rounds of reviews in terms of the security, threatening model review, etc., to make sure we have like a hardened security posture in Symphony as well. And just recently, we released a Symphony Rust crate. This is kind of a Symphony Rust SDK for developing Rust-based providers, which I will go into more details in a moment. So that's the brief update. Like I mentioned, because the team is focusing mostly on quality improvement, we don't have many more new features to share. But hopefully in the coming months, we have some exciting new features lined up. So saying of key features, the first one is, of course, the Rust provider. So as you know, Symphony is written in Go. We chose the Go language because we wanted Symphony to run natively on Kubernetes. Of course, you can run Symphony outside of Kubernetes as well, but we want to have a very streamlined experience on Kubernetes. So we chose the Go language. The challenge of the Go language is that because the code is statically linked, so if you want to extend a Symphony, basically you need to recompile the Symphony binary. And so we heard a lot of feedbacks from different customers. Kyle's team is one of them. Basically, there was a desire to support Rust for various reasons. And from the Symphony's perspective, a benefit of supporting Rust is that, first of all, you can write the Symphony target provider in Rust, and you don't have to rebuild a Symphony binary anymore. And you don't have to contribute source code. I've seen some customers that who's uncomfortable of contributing their providers as source code because they have like some trade secret in their providers. But with Rust, you can just contribute the binary. You don't have to contribute the source code. and the binary is dynamically loaded at runtime. And currently, we do a hash signature check. Actually, we got a pushback from some developers. They want the option to skip that check because it's kind of annoying. Because each time you recompile, you get a new hash, you have to update your artifact. So we'll consider to enable like a dev option so that you can skip the hash check. But in the future, in addition to the hash check, we want to look at other signature mechanisms that we want to also support those so that we don't load like an arbitrary code on the runtime. And first, our first kind of official Rust provider is on Chios. There was also a prototype built for your protocol, which is another Eclipse project. Actually, I'm so glad that we got Ankaio's team on the call. Maybe Chloe, maybe you can say a word or two about Ankaios instead of me trying to explain what Ankaios is.
Yeah, not a problem. So Ankaios is a workload and container orchestrator. So it's kind of an alternative to Kubernetes, but more like targeted to embedded environments. So the idea is that the resource usage is way lower. So it doesn't support all the features, of course, provided by Kubernetes, but just concentrates on the most important things that are needed in an embedded environment. So we are especially targeting automotive, and it's more like on the lower level than of the system, so to speak. So if you need some connectivity to the cloud, something external to Ankaios needs to be provided, where Symphony now comes into the play, so to speak.
Great, thank you for the introduction. Yeah, so we see an opportunity between Symphony and Ankaios, right? I think I have a diagram in the next slides. So basically, Ankaios is this, I would say, a lightweight orchestrator that can run on a car or on a light edge device to provide workload orchestration. And what Symphony can do is to do like a fleet management style of deployment from the cloud, right? You can centrally control like a multiple cars or fleet of devices. This is what this diagram is about. So on the cloud we have Symphony, where you can like design your solutions, your target topology, etc. Then we have this connection to a Symphony agent on the car, and on the car we have the Ankaios infrastructure that which contains the Ankaios server and also one or multiple Ankaios agent. So what's interesting is that the way we deploy this Symphony agent is that we just register this Symphony agent as a regular Ankaios workload. So Ankaios is actually managing that Symphony agent, which you will see in a moment. And inside the Symphony agent, we'll load this Rust-based Ankaios provider. And because this Symphony agent is an Ankaios workload, it has access to the named pipeline to Ankaios agent, which has the access to Ankaios server. So in this way, this Ankaios provider can actually use the Ankaios functionality in the security channel to deploy additional user workload like this, right? And I think in the design, Ankaios support multiple runtime. Currently, we are using the Podman runtime, where you can host your user workload. So that's the like ideal situation. That's how we see the deployment would happen. But in today's demo, I'm going to show a simplified version. Essentially, I'm just going to deploy Symphony as an Ankaios workload. Then I will access the Symphony API directly from the local endpoint. Then I will deploy a simple payload through the OnChios API. So this is a simplified architecture, just to facilitate the demonstration. But the only difference is that we are invoking the Symphony API locally instead through a global instance. So everything else is the same. So let's actually go to the demo part. So I think currently my system is quite clean. If I do Podman PS, there's no pod is running, and my OnChios agent and OnChios server are all stopped. And if I do etc OnChios state, so basically in OnChios I can define the desired state of my system. So in this case, I'm saying my desired state will be having this Symphony container running with these parameters. And once I start the OnChios system, it will find this state definition, and then it will launch the container for me. So this is what I mean that the Symphony agent is actually managed by OnChios in this case. And from Symphony's perspective, it's actually just running in a standalone mode. Like I mentioned, right, Symphony runs natively on Kubernetes, but if you take it out of Kubernetes, it still works. So basically, you just need to give the Symphony a different configuration file, and you turn off the service account tokens. So this environment variable is for the integration of like in the case if you use Kubernetes or AKS, where you have like a pod identity, then we bootstrap that identity automatically, so you don't need additional authentication. But when you're running outside of Kubernetes, you need to turn that off. So we fall back to our own authentication mechanism. So that's the state. Now I'm going to start the OnChios system. System CTL start and server and agent. And almost immediately you can see the Symphony workload is getting launched, right? It just updated 1 second ago. And OnChios also have this command line tool. If you do like a get workload, you can see the Symphony agent is actually running as a OnChios payload. So then now the agent is ready, we can start to use Symphony APIs to deploy OnChios payload. But before that, let me show you the artifact we are going to use. If I find correctly here. Okay. So in case you're unfamiliar with Symphony, so basically to work with Symphony, you need 3 basic objects. I mean, Symphony is all REST-based, so you interact with the API by manipulating Symphony objects. So the first object is a target. So target represents, in most cases, a piece of hardware where you can deploy your workloads. But in reality, a target is just an endpoint to where you can deploy a workload. So it can be a machine, or can be a cluster, or can be like a data center, whatever, right? As long as it can take a payload, then it can be a target. So in this target definition, I have the name. It's called OnChios target. And the key part of the target definition is this binding. So basically, this binding is saying, if you gave me an OnChios workload type, I will call this OnChios provider, call this RAS provider, and then I will load the OnChios RAS provider binary by checking this hash code. Then all the state-seeking operations, like get the current state, applying the new desired state, is all handled by this provider. And the other thing to point out is that we try to encapsulate knowledge of a specific platform to a single provider. So in the case of Ankyos, the only component who understands Ankyos system is within this Ankyos provider. So if you go out of this provider, there's no Ankyos concepts at all, right? So this allows us to make sure that we can, first of all, we can loop in new systems without impacting the rest, and we can like opt out system as well, so because each underlying toolchain system is isolated by its own provider. So that's the target. And solution is actually straightforward, right? Solution is just a workload or software you want to define, which contains one or more components. In a simple case, it has a single component. And in the component, you have a type. This is Ankyos workload. This type is used by the target to choose the correct provider to use, right? And the solution component can have like arbitrary properties. We don't have a fixed schema. You can actually put in any properties required by the provider. So to use the provider, you need to understand what the provider is expecting. So in this case, the provider is expecting a few parameters from the component. I mean, in this case, the provider chose to use this format. But in some other providers, for instance, the Helm provider, they just chose to use the existing Helm chart format. So in that case, basically the property just has one property, says Helm chart. Then you embed the actual Helm chart or Helm chart reference through a URL into this solution. So it's really flexible. It's all about how the provider chose to expose those configuration settings. And once you have the solution, which is software, and target, which is hardware, then you can create a deployment, which is called instance. And the instance is actually quite easy, right? Basically, we say we take this solution and we put on one or more targets. And you can see this notation of solution column version. So this is a relatively new addition to the API because we've heard feedbacks that user wants to have this multi-versioning management experience. So to support this, we actually introduced another component type, which called the solution container. So this is nothing but a container of multiple solutions. Then, because it maintains this list of solutions, we have the sense of older versions and newer versions. This allows us to do things like rolling forward, rolling backward, etc. Right? I think in the future version, the intention is to rename this solution container to solution and solution to solution version, so that it's easier to understand, because this solution container is kind of an obscure concept at the moment. But this is just a point in time situation. So now I'm ready to provision these artifacts. So basically, I will create a target, solution container, solution, and then I will create an instance. And when you're running inside of the Kubernetes, you can use kubectl to interact with Symphony API. But when you're outside of Symphony, basically you use REST API. So the first thing we need to do is to get a security token. Sorry, I have many command lines. So if I do token, yeah, now I have the token. Now I can start to create objects. I think the first one I want to create is this target. So basically, it's just a post request with my target JSON file to the target endpoint. So I'm going to create a target. Then I'm going to create the solution container. Then the solution itself. Okay. No, nothing happens, right? I just defined a bunch of artifact. And now I'm ready to do the actual deployment. I do this by creating an instance object. Did I go past that? Okay, so another post request to the instance object. Now the instance object is created. This will go through Symphony and into the Symphony agent and into the Ankylos provider and into the Ankylos system. So if I do Podman PS, you can see this Nginx is launched 14 seconds ago. And if you do an nk get workload, you can see actually this is actually the Ankylos payload that we deployed through the Symphony management plane, right? This is see how we can seamlessly integrate Symphony and Ankylos system together, so that Ankylos system, I mean, we are not doing anything on the card or on the edge, right? So the workload orchestration is still totally handled by Ankylos itself. So we're not interfering with that process. Symphony is just using the standard Ankylos API to do a payload. And what Symphony does is to manage that consistency on the cloud side, so that you have this, like, for instance, if you want to do a fan-out deployment, you can do that through Symphony. But at the end, all the workloads are still managed by Ankylos itself. So that's the demo. And the next one is another feature we are actually working on is the remote agent. So another historical background. Initially, the Symphony doesn't have a separate remote agent. Basically, the Symphony API is a single binary, and it's lightweight enough. I think when I was first initially working on it, it was about like 60 to 80 megabytes. So basically, I didn't bother to write another remote agent, and I just provide a different configuration file so the API can work as an agent. Then, as we have more developers joining the team, there was a complaint about, okay, so we are reusing the code. So the code sometimes behaves as an API server, sometimes behaves like an agent. So there are some like actual conditions in the code, which makes the code less clear. So there's an effort to create like a new dedicated agent. By the way, I think this is a common misconception for people who's new to Symphony. Symphony actually doesn't mandate a remote agent. This is because the Symphony provider, when we talk to an underlying system, we just use whatever the tool chain is appropriate for that system. So we don't really need our own agent to be on the other side. As long as that system provides some remote management interface, we can just directly work with that remote management interface instead of throwing through our own agent. You will need a Symphony remote agent is that when the device doesn't offer such an interface, and you want to use a Symphony agent to enable this interface, that's the only case you need an agent. For instance, when you try to deploy to, let's say, to a Windows machine, right? You want to deploy a Windows application. Of course, Windows has like a different remote management interface available as well. But in the case that you want to put your own agent on your box and then use Symphony to talk to that agent, that's where you need this remote agent. And Symphony allows different ways to communicate with the agent. We can communicate over HTTP or MQTT, and the agent can also use a polling interface so that it's just there's no inbound connection to the agent, right? The agent opens the outbound connection to the management plane and get the new desired state. And part of this effort, we also worked on the bootstrapping process. So this is for a device maker to onboard a new device with the Symphony agent to the ecosystem. So basically, the process is kind of a typical device onboarding experience. We assume that during the manufacture process, the device is baked with a bootstrapping certificate. And when device boots up, the certificate will be presented to Symphony. And based on the configuration, it can use that to exchange a working certificate. Then basically the mutual authentication happens using the certificate. And this new remote agent is also adopting the new asynchronous paradigm. So everything is like a task-based. Currently, it's just doing state reconciliation tasks, but we are going to extend this agent to support workflow stages, right? The Symphony has its own workflow engine, and currently the workflow engine support remote execution of a stage on the remote machine. This is done through a proxy processor at the moment. We are trying to merge that functionality into this new agent. So basically, the workflow stage execution will be just part of the agent functionality because it's just another task type we need to offer. But this remote agent is not like written from ground up, right? We're still reusing the existing mechanisms of Symphony. For instance, all those protocol bindings, all the middleware we have, like open telemetry, authentication, tracing, those are still available. And also all the current providers still work with this new agent. So currently this feature is in active development. Hopefully we can merge this in probably May timeframe. Once we have that, you will be able to use this remote agent on the scattered devices. Then you can do remote management to those devices. And then we come to the community content. In case you don't know, we do have a Symphony YouTube channel. And on YouTube channel, we have a playlist called Symphony Unscripted. So basically, this is just me sitting down for like 5 or 10 minutes to talk about random topics. We actually have 2 more episodes coming soon. They are already recorded. We're just in the post-processing stage. And we'll keep doing this, right? And if you want to participate in the Symphony Unscripted, just shoot me a message. I can come to you, or we can arrange a meeting, and we can talk about Symphony topics from your perspective. And on the Symphony repo, we also have a new retail scenario. So this is a kind of like our new multi-OS scenario, where you deploy some backend to a Kubernetes cluster, and then you deploy a Windows application as a frontend. Currently, it's under the remote agent branch, but you can certainly take a look before we merge that. And once it's merged, I think we'll present that in the upcoming community call as well. And also on my LinkedIn account, I've been writing about how Symphony works, because in some cases it's kind of hard to explain the Symphony for a couple of reasons. The first is that Symphony makes the most sense to like large enterprises. And if you look at the problem with very small scale, let's say you're using Kubernetes all the time, you're deploying Helm chart all the time, then it's very hard to see the value of Symphony. Actually, I keep telling people, if you are happy with a single tool chain like Helm, then you don't need to look at Symphony, right? Just use Helm on Kubernetes, you'll be fine. Kubernetes comes in when you have to deal with multiple tool chains together. Like if you have different OS systems, different payload types, different devices that use different tool chains, that's where Symphony can bring value. And in this blog series, basically, I was working through some like design reasoning behind the Symphony, hopefully to provide some clarity on this, right? And this is also another aspect of the interesting Symphony community dynamic. As you can see, we have a very small community. This is not like another CNCF project which has like hundreds of thousands or millions of participants. But the customers who we're working with, like huge customers, right? We're talking about like hundreds of thousands or millions of entities to be managed. So it's kind of interesting how the community is comprised at the moment. But I digress. So those are the community contents. Definitely, I encourage you to check them out. And all of these links are available on the Symphony GitHub repo. We do have a Discord server that you can chime in about anything. And we have a Google group that you can request to join. So to be added on to the mail list and other stuff. And we have the community meeting link, and we have the YouTube link as well. But most of all, we want to see your contributions, right? If you have some feedbacks or questions or proposal, I would highly encourage you to open a GitHub issue. Then we'll just handle in a very transparent way, right? Basically, we are doing Symphony completely in the open. Everything we do is publicly available to everyone. And in the upcoming episode of a community call, I hope in the next month we can do the demonstration of remote agent, maybe remote stage execution as well, but I'm not sure. And I know in the mailing list we're trying to demo some AI-based enhancement as well, but we had to postpone that to the next community call, where we can hopefully to show you new updates to the Maestro, which is the Symphony's command line tool. Basically, you can use Maestro to auto-generate some code, such as generate a new provider based on an API spec, right? So I think that would be exciting, but we have to postpone that because we face some difficulties the implementing the change. So that's all the content I have. I think we still have 14 minutes for questions and comments. And I will open the floor to you, make any comments. And if we don't have comments, we can close a bit early. Okay, I think silence means I explained everything perfectly. So there are no questions. So as a call of content, right? We don't want this community call to be a one-way communication. We do want to see your perspective of Symphony, how you use Symphony, what problem you are facing, etc. So definitely, if you have a topic, big or small, right, and if you have something you want to present, let us know, and we'll definitely schedule a slot in the future community meeting. But at the moment, if there are no questions, we'll just close this call. Thank you again for joining, and I hope I'll see you next time.
Thank you.
Thank you.
Thanks. Bye bye.
Thank you.
Thank you. Bye.
Bye.